Hi guys, last time we looked at y equals mx plus c and how we can find the gradient and intercept by just looking at that format of graph. Now sometimes you may get a graph given to you like this. That is still a straight line graph and still does the same sort of thing, but we need to find out what the gradient and intercept are, So we need to find out what m is and we need to find out what c is. Now clearly we cannot do that from just looking at that immediately. So we have to do a bit of jiggling about. Now I want to be left on my left hand side with just the y bit. So I'm going to take away this 3x from this side, and of course good math tells us that we have to do the same to both sides. So I'm going to have now 4y is equal to minus 3x, and because this is positive 5 I'm just going to put plus 5 there. And then here I should be thinking now about dividing both sides by 4, because I just want the y on that side. I'm going to divide by 4. But when I divide this side by 4, I have to make sure to divide all bits by 4. And you might be tempted here to go into decimals, but actually it's much easier to leave it in terms of a fraction. So I've got y equals minus 3/4 x plus 5 over 4. And top heavy fractions are okay. We're perfectly valid leaving them in terms of top heavy fractions. So here the bit that times the x, as we had up there, is the gradient. So my gradient is minus 3 over 4. Now what does that mean? Well, that means that I go 3 down for every 4 along. And the down came from because it was minus. And my y-intercept is at positive 5 over 4. We don't need to put the positive there, but I think it's something that we should get into the habit of doing, because when it comes out as a negative, then we know where we are. So if I was to look at a second example there, just make it a bit trickier, 5y minus 7x is equal to minus 3. Okay, remember our goal is to just leave y on this side, so we'll start honing in and getting rid of bits along the way. So I will start by adding 7x to both sides, because I need to undo the take away 7x, so we're looking at the opposite operations. Again here we were looking at an opposite operation. So I'm left with 5y is equal to positive 7x, take away 3, and then we have to divide both sides by 5 this time, remembering to divide everything on both sides by 5. So I get y is equal to 7 over 5 x minus 3 over 5. So that means that the gradient is 7 over 5, and what that means is it goes 7 up because it's positive for every 5 along, So you can imagine that's going 5 and 7, 5 and then 7, and it's got this y-intercept which is at -3/5. Now sometimes you might need to convert that to a decimal so you can see it along the scale. So this one would be 1.25. This one is -0.6. That might help you with plotting. You know I prefer fractions. I think they're so much neater. So unless you would ask to plot these, I wouldn't change them into a decimal. I would just leave them as a fraction. Okay, and I think that's all I needed to tell you. So if you're given something in this format or a different format to y equals mx plus c, use your algebra skills, convert it to y equals mx plus c, and remember that m, the thing that times the x, is the gradient, and the other bit is the y-intercept. Okay?